Hi, Chris Good here. I want to show you how I produce the output file for the sample exam SPSS questions. So let's just walk through these really quick. Oxby, looking at different AC/DC songs, Brian Johnson versus Bon Scott. Open the file, Oxby offers. So we'll get that open, Oxby 2008 offers. And it says use the chart builder to create a population pyramid split by singer. Upload the resulting output file. Okay, I'm going to put all of these 5 analyses in the same output file. So step 1 is to go to the chart builder, and let's see, population pyramid is actually a histogram plot, and there it is. That looks like what we want. We want it split by the background music variable. That's who was singing in the background, right? So split by music. It says singer, but look in the data, you can see that there's different singers in there. And we're measuring the distribution variable is the offer that people made. That's what we need, and we're going to leave all the rest of the settings at their default value. That's it. Now, you might not know that in the output file, it would be very helpful to me if you would change the title of this to reflect the question you're answering. So this is sample exam question 1, right? Or answer 1, answer to question 1. That's all you need. Number 2 is open file infidelity. So, oops, sorry. We'll go to our SPSS data file and open the next one, infidelity. We want a clustered error bar chart. Okay, infidelity. This one we want a clustered error bar chart of the mean number of bullets used against self and partner images. If we look at the data, so there's bullets on target with partner's face and with the own face. We want a clustered error bar chart. That's this one. And we're actually going to have to drag both of these variables onto the y-axis to create this new summary variable, right? So that's going to be your index category labels, so partner and self. And we'll click OK. And we're going to cluster those by gender. It's like plot them males and females separately. So we'll cluster those by gender. And I do want error bars. I didn't say what I wanted in error bars. I'm just going to go ahead and stick with 95% confidence intervals. And we'll click OK. There's our graph. And it says here, double click on the chart to change, in your output file, to open the chart editor, change the color of the male bars to black. So you do this by clicking on, once you have the chart editor open, click until the blue bars are highlighted, double click, and then for fill and border, you can change that to black, hit apply, and they'll change. That's good. Close that out. Change female bars to white or no fill, so we'll double click on those. No fill, apply, close. What else do we want to change? Change the fonts of all labels and axes to 15-point Arial. Okay, let's start down here. You can actually just change this in the chart editor. You don't need to double click. So Arial 15-point. Good. Now the x-axis labels. Actually, you know what? You can edit these a little bit. So change that to partner. Change that to own face. You don't have to do that, but let's save a little bit of room. And then with the x-axis label selected, you can change the font, Arial 15. Change this. It's bold, so let's not bold that because it doesn't say bold. It says regular. Arial 15. And we'll do the legend as well. Arial 15, Arial 15, and we're done. We can close the chart editor. It'll update the graph here. Let's change this name to sample exam question 2. Great. Oh wait, it says, does it say get rid of the background? Let's do that just for fun. Alright. So change that background to no fill. That'll look much better. Oh, so much better. Alright. Next, using a repeated measures design, I bolded that for a reason. Matthews conditioned male quail to expect a mating opportunity. Let's open that Matthews et al. 2007.save file. There it is. Use the appropriate non-parametric to determine whether a significant difference between these two conditions. So a 2 levels non-parametric repeated measure or related samples would be the, if I customize test, Wilcoxon signed rank test. You do need to specify what you're going to compare. We're doing signal versus control. Put that in the test field, and we'll hit run. All right. It says it's significant. That's the answer to the first question. Was the difference significant or not? It was. Whether it was or not, which environment produced the most fertilized eggs? To find that out, we need to open the model viewer, and you can see that there's more negative ranks here than positive ones. But if you read here, it tells you the direction it's subtracted. It's control minus signaled, and if it's negative, that means signaled had more. So the male that was conditioned fertilized more eggs, or it's the same males. So when they were conditioned, they fertilized more eggs. That's the answer. Close that out. Change this to sample exam question 3. All right, coming right along. Letter grades in the undergrad math course. Use and predict letter grades in the first year grad stats. Open the file grades and use the appropriate analysis to determine whether ordinal data are significantly related. Well, it's a correlation, but since they're ordinal, we can't use Pearson's product moment. Let's open the file grades. So we need a correlation. It's a bivariate correlation, and we want to correlate these two ordinal variables. You notice they're ordinal here. Pearson's not appropriate. We have a lot of ties here, right, in both of the grades, so I'm going to select Kendall's tau. I think we'd still give you credit if you use Spearman's, but you know, that's okay. You guys might not have this option, but I'm going to go ahead and do the BCA bootstrap. And there's our answer. So this is the appropriate analysis. We'll say that this is for sample exam question 4. And they are significantly related. Here's the p-value, right? Here is the R value. So I'd actually write that on my sample exam. Yes, they are significantly related. R is 0.354, P is 0.029. And let's go on to number 5. This is the last one. Time and distance covered by men and women when shopping. Open shopping exercise. Use the appropriate analysis to determine the relationship between time spent shopping and distance. Covered shopping exercise. There it is. But while controlling for gender, that means we're going to use a partial correlation. That's the one that we've discussed so far. So partial correlation control, and we're looking at the correlation between these two variables while controlling for gender. I actually do want to check the 0 order correlations box and the partial correlation options so that I can see what the relationship is without controlling for gender. And I'm also going to bootstrap these. You don't have to, but just for fun, let's check it out. It's still running the bootstrap, and it's done. I'm going to change this. I know it said the bootstrap above, but I'm going to change this to my sample. Oops. Oh, I hate it when that happens. Sample exam question 5. And let's look at the zero order correlation too. So no control variables, that means, and if you look at subscript A, cells contain zero order Pearson correlations. Time spent shopping versus itself, of course, has a correlation coefficient of 1. Time spent shopping and distance walked while shopping is the relationship, the R value is 0.83, P is 0.003, so that's significant. Let's see what happens when we control for gender and look at time spent shopping. Correlated with itself doesn't change, of course. Correlated with distance walked is very similar, actually. So this suggests that gender doesn't matter in terms of the relationship between time spent shopping and distance walked. What was the value for R? It's 0.82. Was it significant? This is your p-value here. Oops, sorry about that. Help. There we go. What was the p-value? 0.007, 007. So I'm done answering the questions. So yes, it was significant. Now I want to save the output file to my desktop, and I'm going to call this, actually I'm going to call it this, sample exam output dash good. I'm just going to put my name in it. That would help me out. I'm going to replace the file that I made earlier. And now we're done with SPSS. So I'm going to close all that out and go to Desire to Learn to upload the file. This is what you're going to do during the exam. I've created a Dropbox. Under the Assessments tab, you can choose Dropbox and upload your file to the output files for Sample Exam 1 Dropbox. If you click on that, this is what you'll see. Submit files. I'll say add a file, and I'm just going to drag my output file, my SPV file, over here and click add. Alright. There it is. I'll hit submit and we're done. Email me with questions at cgoode@gsu.edu and I will see you for our exam.